So this is our Pre-E1.8 assignment, which is just basic graphing, okay? I want to just refresh you on what slope-intercept form is, what general slope is, what the y-intercept is, and how to base just a graph just a basic line, okay? So the first thing we want to talk about is slope-intercept form of a line, which looks like y equals mx plus b, okay? It must be solved for y. Okay, to be in slope-intercept form, it has to be solved for y. Now, once it's solved for y, there's two things we're interested in. The first one is the coefficient on the x variable, this m, and the other is our constant term, which is this b. Okay, when it's solved for y, the coefficient on our x term, m, stands for our slope, which you may remember slope is defined as the change in y over the change in x, which we'll get into more of that in the 119 homework. But really it's just representing the rise over the run. From one point to the other point, how much is the y value either going up or going down? How much is it increasing or decreasing, which is we call our rise? And then from the first point to the second point, how much is our x value changing? Is it going in the positive direction? Is it decreasing? Okay, that we call our run. So slope is our rise over run, and I'm going to go ahead and put over here, we usually want it written as a fraction when we're calculating it. Okay, when it's written in the equation, we don't have to write it as a fraction, but I'm just going to put over here, when calculating, it's helpful to write the slope as a fraction. Okay, and you'll see why in just a minute. Okay, the other thing we said we were interested in is our constant term, which is our b. Okay, what b represents is our y-intercept. And for anybody who might have forgot, our y-intercept, this is the point on the graph where, not when, where the line crosses the y-axis. Where the line crosses the y-axis. Okay, so once we have it solved for y, the coefficient of our x tells us our slope, and the constant term, our b, tells us our y-intercept, which we always write as an ordered pair if they ask for it. Okay, so again here it just says slope is the change in the y variable over the change in the x. I'm fine with you saying rise over run. We're not going to get into the slope formula in this section. Okay, so all I want to do is graph the following lines using slope-intercept form. So again, we want it in y equals mx plus b form. That's our goal. And notice this one's already solved for y. So if this one's already solved for y, that means that I know that my slope is 2 and that my y-intercept is -5. Now we don't write it as just -5 because remember it represents a point on the graph. So I'm going to write this as the point 0, -5, because that's where it crosses the y-axis. Remember, the y-axis is our vertical axis and the x-axis is our horizontal axis. So here I know now that it crosses the y-axis at 0, -5. 1, 2, 3, 4, 5. So I'm going to go ahead and plot that point, and that's going to be my starting point. So I'm going to take that starting point and then I'm just going to count my slope to the next point. Now here my slope is a whole number, so I'm going to go ahead and write it as a fraction. I can write 2 as a fraction by writing it as 2 over 1. Okay, and remember this represents rise over run. So that means from my y-intercept, I'm going to rise 2 and run 1. They're both positive, so my y is going in the positive direction up 2 and in the positive direction forwards 1. Okay, so from this point, I'm going up 2 forwards 1, which gives me this point. Up 2 forwards 1 gives me this point. Up 2 forwards 1, and I can keep going and going and going. Or I could go in the backwards direction. Instead of going up 2 forwards 1, I could go down 2 backwards 1. Okay, so here I'm just going to go down 2 backwards 1, down 2 backwards 1. Okay, and then once we have all of our points, then we just connect our dots with a straight line, which hopefully yours is a little bit straighter than mine, and we're done. Okay, so make sure it's solved for y. Identify your slope and your y-intercept. plot your y-intercept, and then just count your slope to the next points. Okay. Okay, so let's go ahead and look at another one. Okay, now this one's not solved for y, so that's the first thing I have to do is solve it for y. So I'm going to go over here and I'm going to move my x term to the other side. So I have negative 3y is equal to, and I'm going to write my x term first because remember we want it to look like y equals mx plus b. And notice our x term is written before our constant term. So down here I'm going to go ahead and write x plus 6. And then I divide off the coefficient of my y. So I'm going to divide off my negative 3, and I'm going to go ahead and write it under each term so it's easier to simplify. So I end up with y is equal to negative 1/3 x minus 2. And I write it as negative 1/3 because the number on top, the coefficient on the x before I divided it by negative 3 was a 1. Okay, so 1 divided by negative 3 gives me negative 1/3. So here I can go ahead and see that my starting point, my y-intercept, is going to be the point 0, negative 2, and then I look at my slope. From 0, negative 2, my slope is negative 1/3. So I can either put the negative on the top or the bottom, okay? I can do negative 1/3, or I can do 1 over negative, okay? So if I put the negative on the top, that would mean I'm going down 1, forwards 3. Or if I put the negative on the bottom, that would tell me I'm going to go up 1, backwards 3. It doesn't matter. I'm going to go ahead and do it in both directions just so you can see. So my starting point is my y-intercept, which is 0, negative 2. So I'm going to start here. And then from there, I'm going to go ahead and use my negative 1/3. So if my negative's on top, that means my rise is negative. So I'm going to go down 1 and then forwards 3. Down 1, forwards 3. Down 1, forwards 3. Or if you wrote your slope with the negative on the bottom, then since my 1 on top would be positive, I would go up 1 and then backwards 3. So from my y-intercept, I could also go up 1 and backwards 3. Up 1, backwards 3. Okay. Once you have sufficient points, which sufficient to me is usually 3. If you have at least 3, you should be able to tell if your line is looking normal. Okay. Sometimes I like to do a little extra. So. All right, let's look at one more. So again, this one's not solved for y. If it's not solved for y, that's our first order of business because we want it to look like the slope-intercept form of the line, which is y equals mx plus b. So here I need to move my 3x to the other side by subtracting, which gives me 4y is equal to negative 3x minus 8. Remember to write that x term first. And then we divide off our coefficient, which in this case is a 4. So I'm going to divide the 4 off of every single term just so that it makes it easier for simplifying. So I end up with y is equal to negative 3/4 x minus 2. Okay. So here again, I have a y-intercept of negative 2, but remember we write it as an ordered pair. So 0, negative 2, because it represents a point on the graph. So we can't just say negative 2. 0, negative 2. And then we look at our slope. Our slope is negative 3/4. So again, I can put the negative on top with the 3 and do negative 3/4. Or I can put the negative on the bottom and say 3 over negative 4 so that I can get points in both directions. So I'm going to start with my y-intercept, which again is 0, negative 2. So I go to 0 and then go down 2. Again, this is my x, this is my y. And then from my y-intercept, I count my slope. If I do it with a negative on top, that tells me I'm going to go down 3 and forwards 4. So 1, 2, 3, forwards 1, 2, 3, 4. Down 3, 1, 2, 3, forwards 4, 1, 2, 3, 4. Or I could go in the opposite direction. If I go back to my y-intercept, I could go up 3, backwards 4. So 1, 2, 3, 1, 2, 3, 4. Okay. Whoops, my pen died. There it goes. Okay, so then I just connect my dots, draw arrows on both ends, and I have my line. So the only other thing I wanted to point out to you is if you're ever given a line, you can always figure out the slope just by counting it. So let's pretend that I didn't have the equation for this one. If I just had, say, like this point and, I don't know, this point, I could find my slope by just calculating my rise over my run. Okay, my rise going from the first point, which is the higher one, down to the second one, notice I would be dropping down, right? If I have to go down to get to my next point, then my rise is negative. So here, this would be negative. I'm dropping down 1, 2, 3. So for my rise, I would put -3. And then my run is how far left or right am I going from one point to the other. So going from the first point to the second point, again, if I see how far over I'm going in the positive direction, which means it's going to be a positive run, and I count over, which would mean I'm going over what, 1, 2, 3, 4. So if they gave me just the picture and said find the slope, then I would just say my slope is -3/4. Okay, I wouldn't have to put the equation of the line or anything like that. Okay, all right, just wanted to highlight that. You should now be able to do your homework for Pre-E1.8, which is a quiz on my math lab. Let me know if you have any questions. Good luck.